This is your semester 1 exam review or your midterm review. Your midterm is 50 questions, 35 multiple choice, 15 short answer. The first question that we see here tells us to graph the inequality and state the interval notation. So it gives us -3 is less than x, which is less than or equal to 17. We're going to separate this to be two inequalities, one that is the -3 is less than x, the other that's x is less than or equal to 17. For the -3 is less than x, we want to rearrange this to where x comes first. So x is going to go on the left, -3 is going to go on the right. Your sign's originally open to x, so it stays open to x. So on our number line, we're going to have -3 on the left, 17 on the right. That -3 is going to get an open circle, and our line's going to go to the right. The 17 gets a closed circle, and your line goes to the left. These two overlap between the -3 and the 17, so we're going to darken in that area and get rid of anything to the right and the left of that. So with the interval notation, we're just going to have from -3 to 17. That -3 is going to get the parentheses since it has the open circle. The 17 gets the bracket since it has a closed circle. For number 2, you have 4x squared plus 8x minus 7, where x is equal to -3. So we're just going to plug in the -3 for x anywhere we see the x. So that's going to give us 4 times -3 squared plus 8 times -3 minus 7. The -3 squared is 9, so that's 4 times 9. The 8 times -3 is -24 minus 7. Your 4 times 9 is 36. Minus 24 gives us 12. 12 minus 7 is 5. For number 3, you have 6x to the -3rd power, y to the 4th power, all raised to the 2nd power, times 2x to the 9th power, y to the 7th power. If we simplify inside those parentheses first, we're going to have 6 y to the 4th power over x cubed raised to the 2nd power times 2x to the 9th, y to the 7th, all over the first. From here, we're going to apply that power on the first set of parentheses to both the numerator and the denominator. So that gives us 36x to the 8th power, 36y to the 8th power over x to the 6th power times 2x to the 9th, y to the 7th over 1. We're going to multiply this straight across. We can also simplify the x to the 6th with the x to the 9th. That becomes x to the 3rd. Up top on the second fraction. So now we multiply straight across, and this gives us 72 x to the 3rd, y to the 8th times y to the 7th. We add those powers, that's y to the 15th over 1. So that's just the 72x cubed, y to the 15th. For number 4, we have 18x cubed, y to the 5th power over 36, y to the -4th power. We are going to simplify the 18 and the 36 first. 18 goes into 36 twice, so 18 becomes 1, 36 becomes 2. The y to the 4th power is going to go up top, so this is going to give us 1x cubed, y to the 5th times y to the 4th over 2. Your y to the 5th times y to the 4th, we add those powers, so that's just x cubed, y to the 9th power all over 2. For number 5, you have the cube root of 81x to the 6th power, y to the 7th power, z squared. That 81 is 9 times 9. 9 is 3 times 3. Your x is given to you 6 times. 3, 4, 5, 6. Y is their 7th. So 1, 2, 3, 4, 5, 6, 7. And z is twice. So from here, we're going to group up sets of 3 since our index is 3. You have a set of 3 3s, 3 x's, 3 x's, 3 y's, 3 y's. What's left over is the 3, the y, and the 2 z's. So this 3 that groups up, the x that groups up, the other x that groups up, the y that groups up, the second y that groups up, that's all going to be multiplied together on the outside. On the inside, you'll have the 3 that's left over, the y that's left over, and the 2 z's that are left over. So we multiply all of this. This gives us 3x squared y squared times the cube root of 3y z squared. From here for 6, we have the square root of 12 times the square root of 15. Instead of multiplying these two, find the factors of each of them. The 12 is 4 and 3. 4 is 2 and 2. 15 is 3 and 5. So together, the 2's group up, the 5's group up. That's 2 times 3. The 5 stays under since it's left over. So this just simplifies to be 6 square root 5. For number 7, we are rationalizing the denominator in 3 over 2 plus the square root of 5. We're going to multiply top and bottom by the conjugate of our denominator, which is 2 minus the square root of 5. So 3 gets multiplied by 2 minus the square root of 5. And then 2 plus the square root of 5 gets multiplied by 2 minus the square root of 5. So up top, we're going to have 6 minus 3 square root 5. On the bottom, we have 4 minus the square root of 25, which is just 5. So from here, this simplifies to give us 6 minus 3 square root 5 all over negative 1. That then simplifies to give us negative 6 plus 3 square root 5. For 8, we are adding these two polynomials. So we have 3x squared minus 9x plus 11 plus 6x cubed plus 5x squared plus 2x minus 7. We're going to get rid of the parentheses and just combine like terms. And make sure that we put our answer in standard form. So we're going to start with the 6x cubed. Next we have the x squared, which simplifies to be 8x squared. Then we have the x's, so negative 9 plus 2 is negative 7x, and 11 minus 7 is 4. For number 9, we are subtracting, so we're going to have to distribute that negative first. So that's going to give us negative 8x plus 7x squared minus 13 minus 4 minus 3x plus 9x squared. So combine your like terms, starting with your x squared. 7 plus 9 gives us 16x squared. Then you have negative 8x minus 3x, which is negative 11x. And lastly, negative 13 minus 4 is negative 17. For 10, we're multiplying these two binomials. So 6x times 3x is 18x squared. 6x times negative 5 is negative 30x. 1 times 3x is 3x. And 1 times negative 5 is negative 5. Combine your like terms, and that's 18x squared minus 27x minus 5. For 11, you have a binomial cube, so we're going to separate this to where that binomial is next to each other or multiplied 3 separate times. So you have 2x minus 1 cubed. That is the same as 2x minus 1 times 2x minus 1 times 2x minus 1. I'm going to FOIL out the last two first. So it's going to give me 2x minus 1 times 4x squared minus 4x plus 1. From here, I'm distributing the 2x in, then I'll distribute the negative 1 in. So that gives us 8x cubed minus 8x squared plus 2x minus 4x squared plus 4x minus 1. Combine your like terms. The 8x cubed goes down first. Then you have negative 8x squared minus 4x squared, just negative 12x squared. Then 2x plus 4x is 6x minus 1. For 12, we're factoring out the greatest common factor from 9x squared minus 15x plus 3. They're all divisible by 3, so that's going to give us 3 times 3x squared minus 5x plus 1. For 13, we have 16x squared minus 9. It's a difference of squares because you can take the square root of the first and the last term, and it's separated by subtraction. So that's going to give us 4x minus 3 times 4x plus 3. For 14, we're factoring completely. We have an a that's 1, so we're finding the factors of negative 54 that add up to be 3. That would be 6 and 9. If 9 is positive, 6 is negative, that gives us a positive 3. So this is just x minus 6 times x plus 9. For 15, we have 3x squared plus x minus 10. So we're multiplying the 3 times the negative 10. That gives us negative 30. Your factors of negative 30 that add as be positive 1 are negative 5 and positive 6. So this is going to be rewritten as 3x squared plus 5x minus 6x minus 10. And we're going to factor this by grouping. So the first two terms we factor out an x. Second two we factor out a negative 2. That gives us x times 3x plus 5 minus 2 times 3x plus 5. Your two sets of parentheses are identical to one another, so that leaves us with 3x plus 5 times x minus 2. For 16, you're factoring 4x squared plus 26x plus 12. You got a greatest common factor of 2 here, so we're going to factor that out first. That gives us 2 times 2x squared plus 13x plus 6. Your a is not 1, so we're multiplying 2 times 6. That gives us 12. You have factors of 12 that add us to be 13 of 1 and 12. So we're going to rewrite this to give us 2 times 2x squared plus x plus 12x plus 6. Group the first two within the brackets, group the second two, factor out the greatest common factor from both of these. First is going to be x, second is going to be 6, so it's going to give you 2 times x times 2x plus 1 plus 6 times 2x plus 1. Your two sets of parentheses are identical, so that leaves you with 2 times 2x plus 1 times x plus 6. For 17, we're evaluating the expression 7x squared minus 4 over 3x for x is equal to negative 3. So this is going to give us 7 times negative 3 squared minus 4 all over 3 times negative 3. So this is going to simplify to give us 7 times 9 minus 4 all over negative 9. Your 7 times 9 is 63 minus 4 all over negative 9. 63 minus 4 is 59 over 9. Keep the negative out front or with the numerator of your fraction. For number 18, we are simplifying negative 3x to the 4th power y to the negative 7th over 9y squared x to the negative 3rd all raised to the 3rd power. Your negative 3 and 9 are going to simplify to be negative 1 and 3. Your y to the negative 7th goes to the bottom. Your x to the negative 3rd goes to the top. So this is really negative x to the 4th times x cubed over 3y squared times y to the 7th, all raised to the 3rd power. So on the top, that becomes the opposite of x to the 7th power. On the bottom, that becomes 3y to the 9th power. If this is all raised to the 3rd power, that power is going to go to both the top and the bottom. A negative raised to an odd power is going to stay negative. X to the 7th raised to the 3rd is x to the 21st. 3 to the 3rd power is 27. Y to the 9th to the 3rd power is y to the 27th power. For number 19, we are given 8x to the 4th power minus 9x plus 3x squared plus 4 minus 6x cubed. The standard form of this expression is 8x to the 4th power minus 6x cubed plus 3x squared minus 9x plus 4. Your leading coefficient of this is 8. The degree is 4, and your constant is 4. For number 20, you are given x squared plus 3x minus 18 over x squared minus 5x plus 6 times x squared plus 7x plus 10 over x squared plus 7x plus 12. You need to factor all of the numerators and the denominators here and see what you can cancel out before you multiply. So that negative 18 has factors of negative 3 and positive 6. The 6 has factors of negative 2 and negative 3. 10 has factors of 2 and 5. 12 has factors of 3 and 4. So ultimately, this is the same thing as saying x minus 3 times x plus 6 over x minus 2 times x minus 3 times x plus 2 times x plus 5 over x plus 3 times x plus 4. So since we're just multiplying straight across here, you want to simplify first. You have an x minus 3 on the top and the bottom of the first fraction, but diagonally or vertically, you don't have anything else that can simplify. So we just have x plus 6 times x plus 2 times x plus 5 all over x minus 2 times x plus 3 times x plus 4. For number 21, you have x squared plus 6x minus 16 over x squared plus 8x plus 15 divided by x squared minus 8x plus 12 over x squared plus 9x plus 20. Remember, when you're dividing fractions, keep, change, flip. So let's do the same thing you did with the last one. Find the factors first and factor these all out before you keep, change, flip, and multiply. So that's negative 16. You have factors of negative 2 and positive 8 that add up to be 6. 15 is 3 and 5 that give you 8. 12 is negative 2 and negative 6 that give you negative 8. And 20 is positive 4 and positive 5. So this is the same thing as saying x minus 2 times x plus 8 over x plus 3 times x plus 5 divided by x minus 2 times x minus 6 over x plus 4 times x plus 5. So diagonally, you do have things you can simplify here. However, you have to see that after you keep, change, flip. So we're going to keep the first, change to multiplication, flip the second. So that's going to give us x minus 2 times x plus 8 over x plus 3 times x plus 5 times x plus 4 times x plus 5 over x minus 2 times x minus 6. So now diagonally you have the x minus 2 that cancels. You also have the x plus 5 that cancels. So your answer for this one is just x plus 8 times x plus 4 over x plus 3 times x minus 6. For 22, we're evaluating the complex fraction. Remember, these complex fractions mean division. So you have x squared plus 1 over 3x divided by x plus 1 over 9x squared. So that x squared plus 1 over 3x is going to be our first fraction. Our second fraction, we're going to have x plus 1 over 9x squared. So again, we're going to keep, change, flip. We can't simplify anything within those fractions. That's why we're just going straight to the keep, change, flip. That's going to give us x squared plus 1 over 3x times 9x squared over x plus 1. Diagonally, the 3 and the 9 simplify. 9 becomes 3, 3 becomes 1. The x and the x squared also simplify as well. So it's just x squared plus 1 over 1 times 3x over x plus 1. So you multiply straight across, and that's 3x times x squared plus 1 over x plus 1. For 23, it asks us to find the midpoint for the line segment joining the points P, which is negative 3, 7, and Q, which is negative 9, 5. If you remember your midpoint, you are taking the sum of your x values. So you can do x1 plus x2 divided by 2, comma, the sum of your y values divided by 2. So if we use P as x1, y1, and Q as x2, y2, this is going to give us negative 3 plus negative 9 over 2, comma, 7 plus 5 over 2. So from here, we're just going to simplify. Up top, the negative 3 plus negative 9 is negative 12 over 2. For the second fraction, 7 plus 5 is positive 12 over 2. This just simplifies to give us the midpoint of negative 6, positive 6. For your next question, you're finding the distance between the points negative 4, 3, and 5, negative 9. Your distance formula, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to have x2, which is 5, minus x1, which is negative 4, squared plus y2, which is negative 9, minus y1, which is 3 squared. So that's going to give us the square root of 9 squared plus the square root of plus the negative 12 squared. So your 9 squared is 81. The 12 squared, or negative 12 squared, is 144. Add the 81 and the 144. That gives us the square root of 1 plus 4 is 5. 8 plus 4, it gives us 12. Carry the 1, so that's 225. The square root of 225. Your square root of 225 is 15. So this is just a distance of 15. Next, we are identifying the center and the radius from the following. Remember, your formula for a circle is x minus h squared plus y minus k squared is equal to r squared. So your h is going to be the 3. Your k is going to be negative 4, because negative 4 times a negative makes that the positive 4. And your radius is going to be the square root of 81, which is 9. So your center is the ordered pair 3, negative 4. Your radius is 9. For 26, we're writing the equation in standard form with a center of 3, 5, and an endpoint of negative 2, 8. So your first thing that you have to do is identify that your center is h and k. However, you also need to find your distance of your radius. It says a center and an endpoint. Radius is the distance between the center and the endpoint. So we use those 2 points in our distance formula. So your radius is going to be the square root of negative 2 minus 3 squared plus negative 8 minus 5 squared. This is going to give us the square root of negative 5 squared plus negative 13 squared. This then simplifies to give us the square root, radius is the square root of 25 plus the 13 squared is 169. If we add that with the 25, that gives us the square root of 194. That 194 is divisible by 2, but it gives us 97, and 97 is a prime number, so we're not going to be able to simplify that any further. So it tells us that h is 3, k is 5, and the radius is the square root of 194. So if we plug that into our formula, which we said was x minus h squared plus y minus k squared is equal to r squared, that's going to give us x minus 3 squared plus y minus 5 squared is equal to the square root of 194 squared. So simplify that, and that's x minus 3 squared plus y minus 5 squared is equal to 194. For 27, we're determining if the ordered pair 3, negative 7 lies on the line of 1/6 x plus 5 is equal to y. So the ordered pair is our x and our y. If we plug these values in, this is going to give us 1/6 times x, which is 3, plus 5 is equal to y, which is negative 7. The 1/6 times 3 is 3 over 6, or 1/2, plus 5 is equal to negative 7. We know that 1/2 plus 5 is 5 and 1/2, and that is not equal to negative 7. So no, the ordered pair does not lie on the line. For number 28, we're stating the x-intercept of the function 7y plus 9x is equal to negative 2. You're stating your answer as an ordered pair as well. We know the x-intercept is a number, comma, 0, so we're going to plug the 0 in for y. So that's going to give us 7 times y plus 9x is equal to negative 2. That cancels out your 7 and your 0, so that's just 9x is equal to negative 2. Divide each side by the 9. That gives you x is equal to negative 2/9. So again, if we're ordered pair, or if we're giving an ordered pair, that's going to be negative 2/9, comma 0. To find your y-intercept, like in number 29, you are going to plug in 0 for x and simplify or solve for y. State your answer as an ordered pair. So it's going to be 3y is equal to negative 2 plus 8 times 0. The 8 times 0 cancels out. 3y is equal to negative 2. Divide each side by the 3. You get y is equal to negative 2/3. That means that your y-intercept is the ordered pair 0, comma, negative 2/3. For 30, you're finding the slope from the ordered pairs 5, negative 2, and negative 3, 8. So your slope formula is y2 minus y1 over x2 minus x1. That means that you are going to have 8 minus negative 2 over negative 3 minus 5. Your 8 minus negative 2 becomes 8 plus 2, which is 10, over negative 3 minus 5 is negative 8. They are both divisible by 2, so that's 5 over negative 4, or negative 5/5. For 31, you're given the slope of negative 3/4 with the ordered pair 4, negative 2, and writing the equation of the line in point slope form. Remember, point slope form is y minus y1 is equal to m times x minus x1. Your x1 is going to be 4, y1 is going to be negative 2, m is the negative 3/4. So again, point slope form, we're writing it in this form and leaving it in this form. So that means we're going to have y minus negative 2 is equal to negative 3/4 times x minus 4. You do have to simplify double negatives, which we will on the left side here, to give us y plus 2 is equal to negative 3/4 times x minus 4. For number 32, you're given the points negative 2, 3, and negative 4, 7. You're finding the equation of the line in slope-intercept form. So first thing we got to do is find the slope. If we find the slope from these two, we're going to have 7 minus 3 over negative 4 minus negative 2. 7 minus 3 gives us 4. Double negatives turn to positives. Negative 4 plus 2 gives us negative 2. 4 divided by negative 2 is negative 2. If we use that in one of those two ordered pairs in point slope form and then turn it into slope intercept form, that means we're going to have y minus 3 is equal to negative 2 times x minus negative 2. Double negatives turn to positives, so y minus 3 is equal to negative 2 times x plus 2. It tells you to write this in slope-intercept form, so distribute the negative 2 and solve for y. That's going to give you y minus 3 is equal to negative 2x minus 4. You move the 3 over by adding it to both sides, and you are left with y is equal to negative 2x minus 1. For 33, we are finding the slope-intercept form of the equation that passes through the point 9, negative 1 that is parallel, so it has the same slope, to the line 7x plus 3 is equal to 2y. If we solve for y to find what our slope is for this line, we get y is equal to 7 over 2x plus 3 over 2. So the slope of this line is 7 over 2. The parallel slope is 7 over 2 because it stays the same. Then we are using the ordered pair 9, negative 1. So x is equal to 9. Y is equal to negative 1. If we use point slope form, then turn that into slope intercept form, that means we are going to have y minus negative 1 is equal to 7/2 times x minus 9. I'm going to simplify the double negatives and distribute the 7/2 at the same time. So it's going to give us y plus 1 is equal to 7/2 x minus 63 over 2. From here, we're moving the 1 over by subtracting it from both sides. Remember, to add or subtract fractions, you need like denominators, so that 1's going to turn into 2 over 2. So you have y is equal to 7/2 x minus 65 over 2. For our next one, we are finding the slope-intercept form equation of the line that goes through the point 4, 5 that is perpendicular, so opposite and reciprocal slope, to the line 3x plus 4y is equal to negative 2. So we're going to move the 3x over first. We're going to subtract it from both sides. We get 4y is equal to negative 3x minus 2. Then we divide each side by the 4. So we get y is equal to negative 3/4 x minus 1/2. The slope of this line is negative 3/4, which means the perpendicular slope, opposite reciprocal, is 4/3. From here, we're going to use that and the ordered pair, which is 4, 5, and give our point slope form equation. So y minus 5 is equal to 4/3 times x minus 4. We're distributing the 4/3 in, so that's y minus 5 is equal to 4/3 x minus 16 over 3. We move the 5 over by adding it to both sides. Again, you need like denominators. So we are going to have 15 over 3. So that gives us y is equal to 4/3 x minus 1/3. For 35, we're determining whether the relationship represents y as a function of x. If that's the case, your x values do not repeat themselves, but this one has your negative 4 repeating, so this one is not a function. For number 36, you're determining whether the graph represents a function. Remember, if you draw the vertical line anywhere through that function that's given to you, or that line that's given to you on the coordinate plane, and if it crosses through that line more than once, then it's not a function. This one only crosses once, so this one is a function. For your equations, your y cannot be raised to a power that's even, nor can it be inside absolute value bars. So with number 37, you have 3x plus 8y squared is equal to negative 2. This y is raised to the power of 2, so this one is not a function. For 38, you are determining the domain of the given function. You have f of x is equal to 4 times the square root of 7x minus 1. Because you have the square root there, you're going to take the part that's under the square root, set it greater than or equal to 0. So you have 7x minus 1 is greater than or equal to 0. You move the 1 over by adding it to both sides. You get 7x is greater than or equal to 1. You divide each side by the 7. You have that x is greater than or equal to 1/7. You are writing this in interval notation, so if you were to graph it first, you have that 1/7. You're going to have a closed circle on the 1/7. When x goes first, your sign points to the right, so your line runs to the right, which means you're going from 1/7 to positive infinity for your domain. For number 39, your domain of the given function is all real numbers since x is not in the denominator, nor is it under a radical. So that's just from negative infinity to positive infinity. For 40, your domain for this one, since x is in the denominator, you're taking the denominator, setting it not equal to 0, and solving. So you have x minus 9 is not equal to 0. You move your 9 over by adding it to both sides. You have x cannot equal 9. Again, interval notation, if it's not equal to 9, but it's equal to everything else on your number line, you would find the 9. It would be open circles or parentheses, and your line would go to negative and positive infinity. So this just means that it does not include the 9. So we're going from negative infinity to 9 with a parentheses, with a union from 9 with a parentheses to positive infinity. For 41, you have negative 4x plus 9. You're finding f of negative 8. So we're going to have f of negative 8 is equal to negative 4 times negative 8 plus 9. So you're literally just plugging in that negative 8 anywhere you see an x and simplifying. So it's going to give us 32 plus 9, which is 41. So f of negative 8 is equal to 41. For number 42, you have to find g of 0 and 9x squared plus 3x minus 6 over 7x plus 2. So anywhere and everywhere we see an x, we're going to plug in that 0 for it. So that's going to give us g of x is equal to 9 times 0 squared plus 3 times 0 minus 6 all over 7 times 0 plus 2. Anything that's multiplied by 0 cancels out. So we are just left with g of 0 is equal to negative 6 over 2, which is just negative 3. For 43, we have f of x is equal to negative 9x squared plus 7x. We're finding f of 2/3. So that's going to give us f of 2/3 is equal to negative 9 times 2/3 squared plus 7 times 2/3. From here, that 2/3 squared is going to give us negative 9 times 4/9 plus 7 times 2/3 is 14 over 3. Next, you are going to have the 9s that cancel. They become 1 and negative 1. So this is going to give us negative 4 plus 14 over 3. The 4 to turn into something over 3 is going to become negative 12 over 3 plus 14 over 3, which is just 2/3. So let's write this correctly. F of 2/3 is equal to 2/3. For 44, you're finding f of x when x is equal to 4x minus 7 in 3x squared plus 4x minus 2. So anywhere we see an x, we're going to plug the 4x minus 7 in for it. So that's going to give us 3 times 4x minus 7 squared plus 4 times 4x minus 7 minus 2. We're going to separate the 4x minus 7 squared to be 3 times 4x minus 7 times 4x minus 7. From here, we're going to FOIL it out. So that's 3 times 16x squared minus 56x plus 49 plus 4 times 4x is 16x. 4 times negative 7 is negative 28 minus 2. From here, we are going to distribute the 3 in. So 3 times 16 is 48x squared. The 56 times 3 is 168. That's going to be negative. Then the 49 times 3 is 147 plus 16x minus 30, because the negative 28 minus 2 is negative 30. From here, we're going to combine like terms. So we have 48x squared. This is equal to f of 4x minus 7. Let's rewrite that just so we have a little bit more room. F of x minus 7, there we go, is equal to 48x squared. The negative 168 and the 16 give us negative 152x. Then we have 147 minus 30, which is 117. We're going to jump to number 57 because all those ones in between repeat. And we're going to simplify 7x over 2 plus 4x over 9 is equal to negative 3. Your least common denominator here is 18. So we'll multiply the entire thing by 18, which means you're going to do 18 times 7x over 2 plus 18 times 4 over 9 is equal to 18 times negative 3. Your 2 goes into your 18 9 times, so 9 times 7x is 63x. Your 18 and your 9 goes into your 18 twice, so 2 times 4 is 8. Then you have 18 times negative 3, it's going to be a negative. 8 times 3 is 24, carry the 2. 3 times 1 plus 2 is 5, so it's negative 54. From here, we're going to move the 8 over and subtract it from both sides, so that gives us 63x is equal to negative 62. From here, we divide each side by the 63, and we get that x is equal to negative 62 over 63. For 58, you have 4 over 2x plus 1 is equal to 3 over x minus 4. You're going to cross multiply here and make sure that you check for extraneous solutions. So x cannot equal negative 1/2, nor can it equal 4. So then, like I said, cross multiply. So you're going to have 3 times 2x plus 1 is equal to 4 times x minus 4. Distribute your 3 in, distribute your 4 in. That's 6x plus 3 is equal to 4x minus 16. I'm going to move my 4x over by subtracting it from both sides. I'm also moving the 3 over by subtracting it from both sides. So that gives us 2x is equal to 19. Divide each side by 2. That's x is equal to 19 over 2. That is not negative 1/2, nor is it 4, so that's perfectly fine in order to have as our answer. For 59, you are simplifying and checking for extraneous solutions or no solutions in 2 over x plus 3 plus 5 over x minus 3 is equal to 9 over x squared minus 9. Your least common denominator here is x minus 3 times x plus 3. So that 2 is going to multiply by x minus 3, cancels out your denominator. 5 multiplies by x plus 3, cancel out your denominator. 9 is over your least common denominator, so multiply it by 1, cancel out your denominator. So that means we're going to have 2x minus 6 plus 5x plus 15 is equal to 9. Combine your like terms. That's going to give you 7x plus 9 is equal to 9. Subtract your 9 over. You have 7x is equal to 0. Divide each side by 7. You have that x is equal to 0. For number 60, you have 7 minus 3i plus 19 plus 16i. There's addition between these two sets of parentheses, so we're just going to combine like terms, get rid of those parentheses. So 7 minus 3i plus 19 plus 16i. Your 7 and your 19 give you 26. Your negative 3i and your 16i give you 13i. So that's 26 plus 13i. For 61, you have negative 3 plus 8i minus 2 plus 5i. So distribute the negative into the side of parentheses. That gives you negative 3 plus 8i minus 2 minus 5i. So negative 3 minus 2 is negative 5. Your 8i and your negative 5i give you 3i. So that's negative 5 plus 3i. For 2, you are multiplying or foiling out these two binomials. So 6 times 5 gives us 30. 6 times 3i is 18i. Negative 2i times 5 is negative 10i. Negative 2i times 3i is negative 6i squared. Remember, I squared mean negative 1, so we're going to change the sign in front of that 6, cancel out the I squared, and combine like terms. So that's going to give us 30 plus 8i plus 6. Combine your like terms of the 30 and the 6. That's 36 plus 8i. For 63, you have 8i times 2i minus 5. So 8i times 2i is 16i squared. 8i times negative 5 is negative 40i. Simplify that I squared, turn that 16 into a negative 16 minus 40i. It's in standard form. That is your answer. For 64, we have 7 plus 5i times 7 minus 5i. This is a difference of squares, so we're going to do 7 squared. Let's do it in the right color. 7 squared minus 5i squared. So that's going to be 49 minus 25i squared. I squared changes the sign in front of the 25 to be 49 plus 25. Your 9 plus 5 is 14. Carry the 1. 4 plus 3 gives us 7. So that's just 74. For number 65, you're writing the quotient in standard form. You have 4 over 7i. We're going to change that to negative 7i and multiply it by top and bottom. So that gives us negative 28i over 49i squared. Again, that I squared changes the sign on the 49. So, it was already negative. So we're going to change it into a positive. So that's going to give us negative 28i over positive 49. Your negative 28 and your 49 are both divisible by 7. So it's going to turn into a negative 4 and a 7. So that is negative 4i all over 7. For 66, same concept. Take the conjugate of the denominator, multiply top and bottom by it. So we have 3 plus I over 2 minus 7i, or multiply top and bottom by 2 plus 7i. So we FOIL this out. 3 times 2 is 6. 3 times 7i is 21i. I times 2 is 2i. I times 7i is 7i squared. That's all on the top. On the bottom, you have 2 times 2, which is 4. Then different squares here. So 7i times 7i is 49i squared. Again, those I squared are going to change the sign in front of the number that it's attached to. So we have up top 6 plus 21i plus 2i, which is 23i, minus 7 over on the bottom 4 plus 49. This all simplifies to give us negative 1 plus 23i over 53. For 67, you have 2 over x plus 1 plus 4 over x minus 2 is equal to negative 3 over x squared minus x minus 2. Least common denominator is x plus 1 times x minus 2, which means x cannot equal negative 1, nor can it equal 2. The 2 we're going to multiply by x minus 2. Cancel out your denominator. 4 we multiply by x plus 1. Cancel out your denominator. Negative 3 we multiply by 1. Cancel out your denominator. So this is going to give us 2x minus 4 plus 4x plus 4 is equal to negative 3. Combine your like terms on the left. That's going to give us 6x plus 0 is equal to negative 3. Divide each side by the 6. And you get that x is equal to negative 1/2. That's not negative 1, nor is it 2. So that's a solution. For 8, you have negative 9 plus 5i minus 13 plus 4i. We're going to distribute the negative first. So that's negative 9 plus 5i minus 13 minus 4i. Combine your like terms. Negative 9 minus 13 is a negative 22. Your 5i minus 4i is just positive i. So that's negative 22 plus I. For 69, you're rationalizing the denominator in 2 minus 3i over 4 plus I. So top and bottom, we're multiplying by 4 minus I. So we FOIL out on the top. 2 times 4 is 8. 2 times negative I is negative 2i. Negative 3i times 4 is negative 6i. Negative 3i times negative I is positive 3i squared. On the bottom, 4 times 4 is 16. I times negative I is negative I squared. So again, the I squared changes the sign of the term that it's in front of. So that becomes negative 3 up top and positive 1 on the bottom. So this is just going to give us 8 minus 3, which is 5. Negative 2i minus 6i is negative 8i over 16 plus 1, which is 17. For 70, we are solving the equation by factoring. We're given x squared plus 9x is equal to negative 14. We're going to move the 14 over first by adding it to both sides. It gives us x squared plus 9x plus 14 is equal to 0. Your factors of 14 that add to be 9 are 2 and 7. So this is going to give us x plus 2 times x plus 9, x plus 7 is equal to 0. Set them both equal to 0 and solve. You have x plus 2 is equal to 0, x plus 7 is equal to 0. We're going to subtract the 2 over to get x is equal to negative 2. We also subtract the 7 over to get that x is equal to negative 7. For number 71, you have 2x squared minus 11x plus 12 is equal to 0. No greatest common factor, so we're going to multiply 2 times 12. That gives us 24. Your factors of 24 that adds to be negative 11. You have negative 3, and negative 8 that add up to be negative 11. So we're going to rewrite this as 2x squared minus 3x minus 8x plus 12 is equal to 0. Factor by grouping. Factor out an x from the first, a negative 4 from the second. That gives us x times 2x minus 3 minus 4 times 2x minus 3 is equal to 0. Two sets of parentheses are identical, so it's 2x minus 3 times x minus 4 is equal to 0. You set them both equal to 0 and you solve. You get that x is equal to 3/2 and x is equal to 4. For number 72, you're solving using square roots. So take the square root of both sides. Remember, when you do that in an equation, your plus or minus goes in front of your answer. So that's going to give you 3x minus 1 is equal to plus or minus the square root of 7. Move your 1 over, add it to both sides. That gives you 3x is equal to 1 plus or minus the square root of 7. Then divide each side by the 3. You have x is equal to 1 plus or minus the square root of 7 all over 3. For 73, you're completing the square in order to solve. For this one, we want our constant to be moved over. So we're moving the 3 over first. We have x squared plus 4x is equal to 3. You are going to take b, divide it by 2, and square it. That gives you 2 squared, which is 4. That 4 is going to get added to both sides of your equation. So you have x squared plus 4x plus 4 is equal to 3 plus 4. From here, you're going to factor the left side, which is x plus 2 squared. You're going to add the right side to give you 7. Next, take the square root of both sides. You have x plus 2 is equal to plus or minus the square root of 7. Move your 2 over, subtract it from both sides. That's x is equal to negative 2 plus or minus the square root of 7. For 74, we are solving by completing the square. Our constant is already moved over to the other side, so we're going to take that 14 divided by 2 and square it. 14 divided by 2 is 7. 7 squared is 49. That 49 gets added to both sides of your equal sign. So you have x squared plus 14x plus 49 is equal to 13 plus 49. On the left side, that factors to be x plus 7 squared. On the right side, 3 plus 9 is 12. Carry the 1. 4 plus 2 is 6. So we have x plus 7 squared is equal to 62. Take the square root of both sides. 62 is 2 times 31. 31 is prime, so it doesn't factor out at all. So we have x plus 7 is equal to plus or minus the square root of 62. Move your 7 over, subtract it by both sides, and you have that x is equal to negative 7 plus or minus the square root of 62. For 75, you're using quadratic formula to solve. Remember, your quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4. B squared minus 4 times a times c all over 2 times a. So keep that in mind while you're working with these next questions. So using the quadratic formula, your a is going to be 2, b is negative 5, and c is negative 9 here. So that's going to give us x is equal to the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 9 all over 2 times 2. The opposite of negative 5 is positive 5. Plus or minus the square root of negative 5 squared is 25. The negative 4 times 2 is negative 8. Times negative 9 is a positive 72. And this is all over 4. From here, you have to multiply underneath the square root. So that's 5 plus or minus the square root of 25 plus 72, which is 97, all over 4. Same thing with number 76. On this one, your a is negative 4, b is 9, c is 11. So we're going to have x is equal to negative 9 plus or minus the square root of 9 squared minus 4 times negative 4 times 11 all over 2 times negative 4. You have negative 9 plus or minus the square root of 81 plus 4 times 11 is 44 times 2, or sorry, times 4. 4 times 4 is 16. 4 times 4 plus 1 is 17. That's 176. And this is all over negative 8. From here, we add the 81 with the 176. That gives us 7, 15, 257. So negative 9 plus or minus the square root of 257 all over negative 8. You don't necessarily need to keep the negative in the denominator. You can pull it up top. It would just change the 9 into a positive 9. For number 77, you have 12x to the fourth power minus 48x squared is equal to 0. Got a greatest common factor here of 12x squared, so factor that out first. This is going to give you 12x squared times x squared minus 4 is equal to 0. You can continue to factor this, so you have 12x squared times x minus 2 times x plus 2 is equal to 0. Set every part equal to 0 and solve. So you have 12x squared is equal to 0, x minus 2 is equal to 0, and x plus 2 is equal to 0. So from here, divide each side by the 12. You get x squared is equal to 0. Take the square root of both sides. You get x is equal to 0. For the x minus 2 is equal to 0, add your 2 over. You get x is equal to 2. For the x plus 2 is equal to 0, subtract your 2 over. You get x is equal to negative 2. For 78, tells you to factor 2x to the fourth power plus x squared minus 3. Now, since this has an x to the fourth power, you need to keep that in mind. When you do separate it, you're going to have an x to the second power and a 2x to the second power. So, do what you know how to do. A is not 1, so multiply A and C. 2 times negative 3 is negative 6. Factors of negative 6 that add to be positive 1 are 3 and negative 2. So this is going to give us 2x to the fourth power minus 2x squared plus 3x squared minus 3 is equal to 0. Group the first two, group the last two, factor out the greatest common factor. 2x squared from the first, positive 3 from the second. That's going to give us 2x squared times x squared minus 1 plus 3 times x squared minus 1 is equal to 0. So from here, you're going to have x squared minus 1 times 2x squared plus 3 is equal to 0. You're going to set both of these equal to 0 and solve. So we have x squared minus 1 is equal to 0, and 2x squared plus 3 is equal to 0. For the x squared minus 1 is equal to 0, add your 1 over, or you could factor it. It's up to you. You get x squared is equal to 1. Take the square root of both sides. You get that x is equal to plus or minus 1. Two answers there. For the 2x squared plus 3 is equal to 0, subtract your 3 over. You have 2x squared is equal to negative 3. Divide each side by the 2. You get x squared is equal to negative 3 over 2. You're going to take the square root of both sides and rationalize your denominator. So you have x is equal to plus or minus the square root of negative 3 over the square root of 2. Can't keep the negative under the denominator, so pull the I out. Make it positive. You're also going to rationalize your denominator by multiplying top and bottom by the square root of 2. So this is going to give you x is equal to plus or minus I square root 6 all over 2. For 79, you have 3 over x plus 2 minus 5 over x minus 4 is equal to negative 2. Least common denominator is x plus 2 times x minus 4. So your x cannot equal negative 2 or positive 4. So we're going to multiply top fraction or first fraction by x minus 4. Get rid of your denominator. Make it a negative 5 times x plus 2. Get rid of your denominator. And then multiply your negative 2 by x plus 2 times x minus 4. This is going to give us 3x minus 12 minus 5x minus 10 is equal to negative 2 times x squared minus 2x minus 8. If we combine like terms on the left, distribute the negative 2 on the right, we're going to have negative 2x minus 22 is equal to negative 2x squared plus 4x plus 16. From here, I'm going to move the 2x over by adding it to both sides. I'm also moving the 22 over by adding it to both sides. So we have negative 2x squared plus 6x plus 38 is equal to 0. You have a greatest common factor from all three of these terms, which is negative 2. So we're going to factor that out. We're going to have negative 2 times x squared minus 3x minus 19 is equal to 0. So that negative 2 can cancel out. You are now solving x squared minus 3x minus 19 is equal to 0. You cannot factor this, so use your quadratic formula. You're going to have x is equal to the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times a, which is 1, times c, which is negative 19, all over 2 times a, which is 1. So this simplifies to give you positive 3 plus or minus the square root of 9 plus 4 times 19. Your 4 times 9 is 36. Carry the 3. 4 times 1 plus 3 is 7. So that's 9 plus 76 all over 2. From here, this simplifies to be 3 plus or minus the square root of 85 all over 2. This does not simplify, so this is your answer. For 80, you have the square root of x plus 2 is equal to x plus 1. In order to get rid of that square root, we're going to square both sides here. So that gets rid of the radical and the power on the left side to give you x plus 2. On the right side, that foils out to give you x squared plus 2x plus 1. Moving the x over by subtracting it, moving the 2 over by subtracting it, that gives us x squared plus x minus 1 is equal to 0. You do not have factors of negative 1 that add up to be positive 1, so use your quadratic formula. X is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So this is negative 1 plus or minus the square root of 1 plus 4 all over 2. The 1 plus 4 is 5, so x is equal to negative 1 plus or minus the square root of 5 all over 2. For absolute value equations, you want to make sure that your absolute value is equal to a positive number. Separate into two equations and then solve them both. So for 81, you have the absolute value of 3x minus 4 is equal to 17. Your absolute value is isolated. It's equal to a positive number. Separate this into two equations. You have 3x minus 4 is equal to 17, as well as 3x minus 4 is equal to negative 17. For the one on the left, move your 4 over by adding it to both sides. That's going to give you 3x is equal to 21. Divide each side by the 3. You have that x is equal to 7. For the one on the right, you are moving the 4 over by adding it to both sides. You get 3x is equal to negative 13. Then you are dividing by 3. So x is equal to negative 13 over 3. For 82, you have negative 3 times the absolute value of negative 5x plus 13 plus 9 is equal to 36. We're going to move our 9 over first by subtracting it from both sides. We get negative 3 times the absolute value of negative 5x plus 13 is equal to 27. From here, we're going to divide each side by negative 3. Now we have the absolute value of negative 5x plus 13 is equal to negative 9. Our absolute value is isolated. However, it's equal to a negative number. That is not possible, so this one is no solution. For number 83, we have 3x to the 4th power minus 108x squared is equal to 0. We're going to factor out 3x squared first. We get 3x squared times x squared minus 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times is equal to 0. We can separate this to be 3x squared is equal to 0 and x squared minus 36 is equal to 0. For the 3x squared is equal to 0, divide each side by 3. You have x squared is equal to 0. Take the square root of both sides. You get x is equal to 0. For the x squared is minus 36 is equal to 0. We are going to add 36 over. We have x squared is equal to 36. We are going to take the square root of both sides. We get x is equal to plus or minus 6. For 84, you have 3x over x plus 1 plus 2 over x minus 3 is equal to 0. Your least common denominator is x plus 1 times x minus 3, which means x cannot equal 1, nor can x equal negative 3. We are going to multiply the top of the first fraction by x minus 3, cancel out the denominator. Multiply the second fraction by x plus 1, cancel out the denominator. 0 gets multiplied by x plus 1 times x minus 3, which is just 0. So this is going to give us 3x squared minus 9x plus 2x plus 2 is equal to 0. From here, we combine like terms to give us 3x squared minus 7x plus 2 is equal to 0. 3 times 2 gives us 6. Your factors of 6 that add to be negative 7 are negative 1 and negative 6. So this is going to get rewritten to be 3x squared minus x minus 6x plus 2 is equal to 0. Factor by grouping. Factor out an x from the first, a negative 2 from the second. This is going to give us x times 3x minus 1 minus 2 times 3x minus 1 is equal to 0. Two parentheses are identical, so we are going to have x minus 2 times 3x minus 1 is equal to 0. Your x minus 2 gets set equal to 0. Your 3x minus 1 gets set equal to 0. And we solve these both. So we're going to have the 2 added over to get x is equal to 2. The 1 we move over by adding to get x, or 3x, is equal to 1. Then we divide each side by the 3. We get x is equal to 1/3. For 85, you're solving this equation that involves square roots. So in order to get rid of the square root, we're going to square both sides. So it's going to give us negative 5x minus 9 is equal to x squared plus 6x plus 9. The 5x moves over by adding to both sides. The 9 moves over by adding to both sides. So we are going to have x squared plus 11x plus 18 is equal to 0. Your 18 is 9 and 2 that equal out to 11. So we're going to have x plus 9 times x plus 2 is equal to 0. From here, we set them both equal to 0. We get that x is equal to negative 9 and x is equal to negative 2. For 86, we are solving the absolute value equation. 3 times the absolute value of 4x plus 3 is equal to 15. We're going to start this one by isolating the absolute value and dividing each side by that 3. So we get the absolute value of 4x plus 3 is equal to 5. Absolute value is isolated. It's equal to a positive number. So we're going to have 4x plus 3 is equal to 5. And 4x plus 3 is equal to negative 5. From here, move your 3 over. You have 4x is equal to 2. Divide each side by the 4. You get that x is equal to 1/2. For the other one, move the 3 over, subtract it from both sides. You get 4x is equal to negative 8. Divide each side by the 4. You get that x is negative 2. For 87, you have negative 2 times the absolute value of 8x minus 21 plus 3 is equal to negative 19. Move your 3 over first, subtract it from both sides. That's negative 2 times the absolute value of 8x minus 21 is equal to negative 22. From here, divide each side by negative 2. This is going to give you the absolute value of 8x minus 21 is equal to 11. Absolute value is isolated, it's equal to a positive number. You're going to have 8x minus 21 is equal to 11, and 8x minus 21 is equal to negative 11. For the one on the left, move your 21 over first. This gives you 8x is equal to 32. Divide each side by the 8, and you have that x is equal to 4. For the 8x minus 21 is equal to negative 11, add your 21 over. Remember, subtract them since they're different signs. You have 8x is equal to 10. From here, divide each side by 8, and you get that x is 5/4. For 88, you're solving the absolute value inequality and, just solving the inequality, stating your answer in interval notation, and graphing it. For 88, we have 4x minus 13 is less than 7. We move the 13 over first. We get 4x is less than 20. We divide each side by 4, and we get that x is less than 5. On your number line, you're going to look for 5. You're going to have an open circle on 5. Line goes to the left. So your interval notation for this is just from negative infinity to 5 with an open circle, so parentheses. For 89, you're solving 4 times 2x minus 5 is greater than or equal to 5x plus 16. Distribute your 4 first. That's 8x minus 20 is greater than or equal to 5x plus 16. I'm going to move the 5x over first, so I'm going to subtract it from both sides. I'm also moving the 20 over by adding it to both sides. So that gives us 3x is greater than or equal to 36. Divide each side by the 3, and you get that x is greater than or equal to 12. Since our x is first and it's on the left, we draw our number line. We put down the 12. Our 12 is going to get a closed circle on it since it's also equal to, when x goes first, our line points to the right. So our sign points to the right, so our line goes to the right, which means we're going to have a bracket, 12, comma, infinity, parentheses. For number 90, we have negative 8 is less than 4x plus 9, which is less than or equal to 42. We're going to start this one from the very beginning by separating it, so that way we have negative 8 is less than 4x plus 9, as well as 4x plus 9 is less than or equal to 42. For the negative 8 is less than 4x plus 9, I'm going to move the 9 over first. That's going to give us negative 17 is less than 4x. Then divide each side by the 4. So negative 17 over 4 is less than x. We rearrange this to where x is first, so x is greater than negative 17 over 4. For the other one, we're moving the 9 over first. This gives us 4x is less than or equal to 33. Then we divide each side by the 4, and that gives us x is less than or equal to 33 over 4. Your number line, your negative 17 over 4 is going to be on the left. Your 33 over 4 is going to be on the right. You're going to have an open circle on the negative 17 over 4. And your line's going to go to the right. For your 33 over 4, you're going to have a closed circle, and your line's going to go to the left. These two overlap between each other. So the interval notation for this is just from negative 17 over 4 to 33 over 4 with the parentheses on the negative 17 over 4 and the bracket on the 33 over 4. For 91, you are solving x squared is greater than or equal to 3x plus 21. We are going to move the 3x over by subtracting it. We're also moving the 21 over by subtracting it. Writing it in standard form, that's x squared minus 3x minus 21 is greater than or equal to 0. This is a greater than or equal to. Greater or, your inequality is going to be an or statement, so your lines are going to go opposite each other. With this one, you do not have factors of 21 that add up to be -3, so you can solve this by using your quadratic formula. Just remember your rule with the or statement. So you're going to have x is equal to the opposite of -3 plus or minus the square root of -3 squared minus 4 times 1 times -21 all over 2 times 1. So this gives us 3 plus or minus the square root of 9 plus 21 times 4 is 84 all over 2. So that is x is equal to 3 plus or minus the square root of 93 all over 2. 93 is 3 and 31. That's not going to factor out any further, so you're going to leave it in this form. Again, we said it was an or statement, so when we go to draw our number line, your 3 minus the square root of 93 is going to go over 2, it's going to go on the left side. Your 3 plus the square root of 93 over 2 goes on the right side. It is equal to, so you're going to have closed circles on both, and we said from the beginning it's an or, so your lines are going to go away from one another. So the interval notation for this is from -infinity to 3 minus the square root of 93 over 2 with a union, bracket. With a bracket, with a union of bracket 3 plus the square root of 93 over 2, comma infinity. On 92, you have 2x squared plus 5x minus 11 is less than -4x squared plus 10. Move your 4x squared over, add it to both sides. Move your 10 over, subtract it from both sides. So this is going to give you -2x squared plus 5x minus 21 is less than, not equal to, less than 0. You can factor out a -1. I would do that first, so that way you're not working with the negative. So it's going to be 2x squared minus 5x plus 21 is less than 0. Your 2 times 21 is 42. You need to find the factors of 42 that add up to be -5. So 42, you have 1 and 42, 2 and 21, 3 and 14. 4 doesn't go into it evenly, 5 doesn't go into it evenly, 6 goes in 7 times. None of those are going to give you the -5 when you add them together. So what we are going to do is we are going to use the quadratic formula once again. Remember with this is in less than, so it's and. So your quadratic formula, you're going to have x is equal to the opposite of -5 plus or minus the square root of -5 squared minus 4 times 2 times 21 all over 2 times 2. So that opposite of -5 is +5 plus or minus the square root of -5 squared is 25. The -4 times 2 is 8 times 21, which is positive. So that's all negative 168. And this is all over 4. From here, we're going to subtract underneath the radical. So that gives us x is equal to 5 plus or minus the square root of -143 all over 4. That negative has to come out, turns into an I. So that's x is equal to 5 plus or minus I square root 143 over 4. From here, we said that this is an and statement. So on your number line, you have 5 minus I square root 143 over 4. You have 5 plus I square root 143 over 4. We're going to have open circles on both. We said it's and, so it's connecting. So your interval notation for this is going to be parentheses 5 minus I square root 143 over 4, comma, 5 plus I square root 143 over 4. For 93, we're using the function table and we are graphing the quadratic function. F of x is equal to negative 2x squared plus 2. We're given x values of negative 4, negative 2, 0, 2, and 4. So starting off with the negative 4, we are going to have negative 2 times negative 4 squared plus 2. That negative 4 squared is 16. 16 times negative 2 is negative 32. Negative 32 plus 2 is negative 30. So that gives us the ordered pair, negative 4, comma, negative 30. Next, the negative 2 goes in, so that's negative 2 times negative 2 squared plus 2. The negative 2 squared is 4 times 2 is negative 8. Negative 8 plus 2 is negative 6. So that's the ordered pair, negative 2, negative 6. Next, we have 0, so that's negative 2 times 0 squared plus 2. Anything times 0 is 0, plus 2 is 2. So that's the ordered pair, 0, 2. Next, for 2, we have negative 2 times 2 squared plus 2, which is negative 6. That gives us 2, negative 6. And then the 4, negative 2 times 4 squared plus 2. 4 squared is 16, times 2 is negative 32, plus 2 is negative 30. So that is the ordered pair, 4, negative 30. The 4, 30, and the 4, negative 30 and the negative 4, negative 30 is not going to fit on our coordinate plane. However, the negative 2, negative 6 is here. The positive 2, negative 6 is here. And then the 0, 2 is here. So we can draw our line through those ordered pairs, making it look like that U or that parabola that we know it's supposed to look like. For your cubic function, you have g of x is equal to the opposite of x cubed plus 1. We're given x values of negative 2, negative 1, 0, 1, and 2. So for negative 2, we're going to have the opposite of negative 2 cubed plus 1. The negative 2 cubed is 8, or negative 8. Negative 8 times negative 1 is a positive 8, plus 1 is 9. So that gives us negative 2, 9. For the negative 1, that's the opposite of negative 1 cubed plus 1. Negative 1 cubed is negative 1. Opposite of that is positive 1, plus 1 is 2. So that is negative 1, 2. Next we have 0. So the opposite of 0 cubed plus 1. That's just 0 plus 1, which is 1. So that's the ordered pair, 0, 1. Next we have 1. So the opposite of 1 cubed plus 1. 1 cubed is 1. Opposite of that is negative 1 plus 1 is 0. So that is the ordered pair, 1, 0. And lastly, the opposite of 2 cubed plus 1 is negative 8 plus 1, which is negative 7. So that is 2, comma, negative 7. So negative 2, 9 is here. Then we have 2, negative 1, 2. So that's here. 0, 1, 1, 0, and 2, negative 7. So we're going to go up and to the left, down and to the right. For 95, it tells us to use the graph to identify the domain, range, vertex, axis of symmetry, maximum or minimum, increase, decrease, constant, and zeros. So for this one, since it is a parabola, it means that we have a quadratic function, so our domain is automatically from negative infinity to positive infinity. Your range are the y values, so you start at negative 8 and you go up to positive infinity. So your range goes from negative 8 to positive infinity. You have a vertex of the ordered pair that's there for you, which is 0, negative 8. The axis of symmetry is the x value from that, which is 0. Your maximum or your minimum is the y value from your vertex, which is -8. It also is a parabola that opens up, so you have a minimum value. Next, it tells you to state the increase, decrease, and constant. Your increase is where it goes up from left to right and the x values in which that occurs. So that's from 0 to infinity. Your decrease is where it goes down from left to right, and those are the x values in which that happens. So that's from -infinity to 0. And your constant is the part of the graph that is flat, which in this graph there is none, so it would just be none. For number 96, we're using the graph to identify the domain, range, increase, decrease, and constant. For the domain for this graph, you are going from -infinity up to 11. So all of those x values are being covered from -infinity to 11. Your range, it's the lowest y value, which is -infinity, up to the highest y value, which is 5. So that one goes from -infinity to 5. Your increase, look at where the line goes up from left to right and the x values in which it occurs. That goes from -infinity to -5, as well as here. So that's from -2 to +2. Next, we're looking at decreases. So that happens here from -5 to -2, as well as here from 7 to 11. So your decrease is happening from -5 to -2, with a union from 7 to 11. Constant is the part that's flat, so that's happening here, which is from 2 to 7. For 97, we're doing the same thing we just did in 96. So domain, range, increase, decrease, and constant. Your domain for this one goes from -10 to +infinity. Your range, lowest y value is -9. Highest y value is infinity because that arrow that's on the way to the right. Increase, you're going up from -10 to -7, as well as 3 to 6 to +infinity. So that's from -10 to -7, with a union from 3 to infinity. Your decrease going down from left to right, so that's from -7 to -4, and then from 0 to 3. Lastly, your constant goes from -4 to 0. Next, you are using long division to divide x cubed plus 6x squared minus x minus 30 divided by x minus 2. So that x minus 2 is going to go on the outside. X cubed plus 6x squared minus x minus 30 goes on the inside. From here, your x times x squared is x cubed. You multiply that by the x and the -2. From there, you will subtract, distribute your negative, change the sign on everything. This gives you 8x squared. Bring down the next term, which is -x. Next, you have the x times what is 8x squared? That's 8x. So 8x times x is 8x squared. 8x times -2 is -16x. Subtract these, distribute your negative, change the sign on everything. That gives you 15x, bring down the negative 30. So x times 15 is 15x, minus 2, or times negative 2 is negative 30. Subtract these, distribute your negative, change the sign on everything, everything cancels. So your answer for this one is just x squared plus 8x plus 15. For number 99, you're using synthetic division to divide 3x to the 4th power minus 6x squared plus 2x minus 4 divided by x minus 4. That x is equal to 4. You're also missing a 0x cubed, so plug that in. The 4 is going to go on the outside. On the inside, you're going to have 3, 0, negative 6, 2, negative 4. 3 drops down. 3 times 4 is 12. Add that with the 0. That gives you 12. Times 4 is 48. 48 minus 6 is 42. 42 times 4, the 2 times 4 is 8. 4 times 4 is 16. Add that with a 2, that's 170. 170 times 4 times 0 is 0. 7 times 4 is 28. 4 times 1 plus 2 is 6. Subtract 4 from that, and that's 676. That's 676 is your remainder. 170 is your constant. 42 gets x. 12 gets x squared. 3 gets x cubed. So your answer for this is 3x cubed plus 12x squared plus 42x plus 170 plus 676 over x minus 4. For 100, it tells you to use either long or synthetic division to divide 7x cubed plus 2x squared minus 12x plus 3 by x plus 9. X is equal to negative 9. I'm going to use synthetic division just because I think it's easier. Negative 9 is going to go out front. Inside, you're going to have 7, 2, negative 12, and 3. 7 drops down. 7 times negative 9 is negative 63. Plus 2 gives us negative 61. A negative times a negative is a positive. So we will have a positive when we multiply. 61 times 9 gives us 549. Subtract 12 from that. That gives you 537. Times negative 9 is negative 4,833. Add the 3 to that, and that gives you negative 4,830. That's going to be your remainder. Constant is 537. Negative 61 gets x. 7 gets x squared. So that's going to be 7x squared minus 61x plus 537 plus negative 4830 over x plus 9. For 101, it tells you to use synthetic division and the remainder theorem to evaluate. You're finding P of x is equal, or P of negative 1 really, is equal to 4x squared plus 12x plus 5. So the negative 1 is going to go on the outside. On the inside, you have 4, 12, and 5. Whatever your remainder is, that's your answer. 4 drops down. 4 times negative 1 is negative 4. Plus 12 is 8. 8 times negative 1 is negative 8. Plus 5 is negative 3. The remainder is your answer here. So P of negative 1 is equal to negative 3. For 102, you're using synthetic division and the remainder theorem to evaluate. Your negative 2 is going to go on the outside. On the inside, you have 6, 0, 10, 0, 1, and 1. So you're plugging in zeros for the x to the 4th and the x squared. 6 drops down. Times negative 2 is negative 12. Plus 0 is negative 12. Times negative 2, positive 24. Plus 10 is 34. Times 2 is negative 68. Minus 0 is negative 68. times 2 is a positive 136, plus 1 is 137, times negative 2 is a negative 14, carry the 1, 6, 7, and then 2. So that is negative 273. Again, your remainder is the answer here, so P of negative 2 is negative 273. For 103, you are showing that the given value of x is 0. So we're going to start with negative 2. We have 3x to the 4th power minus 8x cubed minus 14x squared plus 31x plus 6. Start with negative 2, then check the 3. So the negative 2 is going to go on the outside. On the inside, you'll have 3, negative 8, negative 14, 31, and 6. Your 3 drops down. 3 times negative 2 is negative 6. Negative 8 minus 6 gives us negative 14. Times 2 is 28. Minus 14 is 14. Times negative 2 is negative 28. 31 minus 28 gives us 3. Times negative 2 is negative 6. That gives us 0. We're looking for the 0. So yes, that negative 2 is a 0. From here, we are going to use what we have left over, which is the 3, the negative 14, the 14, and the 3. And we're going to use synthetic division with 3. See if we get 0 as a remainder for that one. So 3 drops down. 3 times 3 is 9. That gives us a positive 9. Negative 14 plus 9 is going to give us a negative 5. Times 3 is negative 15. 14 minus 15 gives us a negative 1. Times 3 is negative 3. 3 minus 3 is 0. That one is also a remainder of 0, so 3 is a solution as well. So both the negative 2 and the 3 are solutions. For 104, you have P of x is equal to x cubed minus 5x squared minus 2x plus 10, where x is equal to 5. So we're showing that 5 is a solution here. So 5 is going to go on the outside. On the inside, you're going to have 1, negative 5, negative 2, and 10. 1 drops down. 1 times 5 is 5. Minus 5 is 0. 0 times 5 is 0. Plus negative 2, or minus 2, sorry, is negative 2. Negative 2 times 5 is negative 10. 10 minus 10 is 0. That gives you 0 as a remainder. So 5 is a solution.